Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 17 and in this lesson we'll learn about how to interface Nokia 5110 LCD to the Arduino. Okay. We also provide online training, help in technical assignments. We also do freelance projects based on Matlab, Python, data science, machine learning, embedded system, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. Okay, so as we discussed in this lesson, we will be talking about how to interface this Nokia 5110 LCD. So let's first have a discussion about the hardware, how this LCD looks like and what are the pin configurations of it. So here on screen you are seeing this Nokia 5110 LCD. So generally it has total 8 pins. Now different LCD configuration could have different pin names associated with the pin numbers. So the LCD which we are using, those pin numbers and their pin name are as per this table. So first pin is for VCC, second pin is for ground, third pin is for SCE, is chip enable, and fourth pin for RES, and fifth one D/C. Right, so this oblique C is the data and command selection, and then another pin is SDIN. So generally this SDIN is also there are several names for this SDIN. This can also be sometimes written as DN, or in some pin it can be written as MOSI. Okay, master out slave in. And then other pin number 7 is clock, which has to be applied, uh, and then which is last pin to control the backlight. Okay, so these are the pin numbers, and we will be connecting this to the Arduino. So prior to moving forward, let's go about this LCD. So this Nokia 5110 has total 84 cross 48 pixels. So these are the pixels number. That means they are total 84. They are total. So they are total 84 columns, right? Like this one, and there are 48 rows pixels in it. Okay, so and the and we can divide this particular rows and column of pixel configuration into words and to display the words. So we can divide into 14 cross 6 for columns and 6 cross 8 for rows. Right, so here this 14 represents the number of columns or number of character which can be displayed in a row, and there are total 6 rows could be there. Okay, so total column are make up of 6 pixels. So let's say these 6 pixel columns are used to make a row, make a column, and vertically 8 pixel are used, or 8 pixels are used to make a rows. So total we can represent this is as row wise, these are as rows, and these are as columns. So total we can represent 14 character in a single row, and we could have total 6 number of rows as well. Okay, so this particular numbers represents like how many pixels which we are going to use to display any specific character. Okay, now there are some header files which has to be included in it. So the header file which we are going to include, that is Adafruit header file pcd 8544 .h file. So this is a driver header file which is used for displaying some of the characters on this LCD. Now there are some functions associated with it, so those are very straightforward. First of all, we need to write lcd.begin in order to initialize the LCD in this 84 cross 48 mode, and then there are another command like lcd.print. So if we want to print any uh, string in it, then that can be printed here directly like this. Okay, so these are the functions which we'll be dealing with when we will be writing a program. So now coming to the connection diagram as well. So here we have our Arduino, and we have seen these are the pin numbers of this one, so we can make a copy of it. Okay, so here it looks like fine. Okay, so the connections goes like this. Pin number 5, these are the pin number of this Arduino. Pin number 5 of this Arduino is connected to the D/C pin. So D/C pin is the data and command, that is the pin number 5. So pin number 5 of this is connected to the pin number 5 of this LCD. And then pin number 4 is connected to MOSI. So pin number 4 MOSI, or we could say the SDIN. So pin number 4 is connected to the pin number 6, this one, and then pin number 3 is connected to the serial clock. So we can take it like this. Serial clock is pin number 7, and then backlight is connected to 3.3 volt. Then pin number 6 of this Arduino, which is this one, it is connected to the reset pin of this LCD. So that is is pin number 4 of the LCD, like this. And the pin number 7 is connected to the chip select, which is pin number 3 of the LCD. And then this is connected to plus 3.3 volt, and this is also connected to plus 3.3 volt, and the last pin, which is pin number 2, this is connected to ground. So these are the circuit diagram, circuit diagram or the connection diagram, which should show how this Arduino UNO pins are connected to this LCD. Okay, so now let's coming to the coding part of it. We will open this one, this Arduino, and we will create a new file. And in new file, first of all, we will save it. So let's save on desktop. We can write it lesson 17 Nokia 5110. Save. Okay, so as we discussed, first of all, we have to add the header file of it. That is, let's go here. So let's add header file hash include, which is pcd8544.h. Okay, one more thing, you have to download this header file prior to installing it, and it is easily available on internet. This is a Adafruit header file. Okay, you can then add this header file to the library, like from include library and from add zip folder, add zip library. And in our system, you just have to give a path where this header file is stored. So in our system, it is stored here somewhere. Yep. Yeah, this one, pcd8544_master. So if you want to download, we will also add this header file to our website. So if you wish to download this header file, you can download it from there as well. So we have already included this header file, and then we have to create a LCD object first. So that can be created by making it a static as, so static, then pcd8544, that is a object, and then we are creating a LCD object of it. Okay, now first of all we have to simply begin. So lcd.begin, and it is 84x48, and then In a loop, first of all we need to set cursor at which location we want to print the data. So that will be lcd.setCursor, and its location should be, first should be the column. So let's say column 0 and row 0 we are writing, and we are simply displaying a simple character. Let's say lcd.print, we will be writing JCBRO LABS. So as we discussed, we can only display 14 character in this configuration. So right now there are 1 2 3 4 5 6 7 8 9 10. So there are total 10 characters right now. So we will save it and we will compile it, and we'll generate a hex file of this, and then we'll create a simulated model on the Proteus, and then first we'll simulate it and then we'll move forward on the hardware. Okay, so let's export this compiled binary. Okay, and now coming to the Proteus, we'll create a new project. And we'll make this new project in the same folder, which is, and we will make the name of the project as Nokia 5110. Nokia 5110. Okay, next. So let's first of all check this Arduino. So if you are not familiar with how to include this Arduino library in our Proteus, so we have created another file, another video on the same, so you can go through that. So this is our Arduino. Let's select it. Okay, and then let's select this Nokia 5110. Okay, here it is. So we will do the connection as we discussed. So pin number 7 was connected to pin number 3. So pin number 7 is connected to this SCE pin, that is pin number 3. So we'll provide some space, and then pin number 6 is connected to the RST reset. So just go through those circuit diagram which we created here, and pin number 5 is connected to pin number 5, that means D/C, data or command, and then pin number 4 is connected to DN, and then pin number 3 is connected to clock, serial clock is there. Right, now pins are done. We have to provide some power supply, so let's go to power. So this power has to be connected to ground, VCC, and the last LED. Now we need a ground as well, so we'll select ground. Okay, let's put it here. Okay, let's connect this ground. Okay, that's fine. Now we let's save it, and we have to provide the hex file which we have generated from Arduino. So go to program file. This hex file has been generated. We'll say open it, and then okay. So that's it. Now we have to run the program. Okay, so JCBR is there. That's it. Okay, let's stop. Let's write something else as well. Okay, so now let's say we want to display a single character. So we'll set the cursor position to, let's say, third column. So it is pixel wise, remember. Okay, and then row number 2, and then we'll write LCD dot. So if you want to display any single character only, we have to use this LCD dot write command. So here let's say we will display J, and now let's write another word as well. So let's change to cursor and make it third location, comma, last line of the LCD. and then we'll write lcd.print. We can print like India. Okay, so that's it. That is a simple program. Let's save it and let's generate a compile binary, or I should say the hex file. So in order to generate the hex file, you just have to click on this export compile binary, and that hex file is auto loaded on unit. And then let's run this program. Okay, that's it. JCBRO labs, J and India. So the column number which we specified, like third column, so that is the pixel wise, and the column which we specified like 14 cross 6, right? Remember this 14 cross 6, this was for the column number for the characters, like 6 pixels are being used for displaying a single character in column wise. So in total we could display these 48 characters. So this is how we can done on simulation. Now let's move towards the hardware, on real hardware, and then let's see, let's download the same program on the hardware and see how it looks like. So you can download, just click on this one. This will be, the program will be downloaded on the hardware. So let's see how, on hardware, how it looks like. So this is our hardware setup, and here we have, this is our Arduino, and here we have this our Nokia 5110 LCD. And in this LCD the pins are connected as we discussed in our diagram. This is VCC ground, and then this pin is connected to pin number 7, and in a sequence like 7 6 5 4 3, and the last pin is the backlit LED, and it is displaying like JCBRO labs and J and then India as we write a program into it. So this is how we can display any characters or any sensor data or any other information on this Nokia 5110 LCD. Okay, so you have seen the program was working fine on hardware as well. So I hope you understand how to interface this Nokia 5110 LCD using Arduino, and you can really create a very cool stuff like displaying temperature sensor or several other information on this LCD. So this is how we can do it. Further, we also provide online training, help in technical assignments. We also do freelance project based on Python, data science, machine learning, Matlab, embedded system, etc. So if you have any such requirement, then you can let us know by contacting below this video, or you can also mail us at jcbrolabs@gmail.com. So that's it for this video.